Okay, so now let's talk about dealing with overplotting, which begins on page 69 of the textbook. There's a number of plots, predominantly the scatterplot, where overplotting can be a problem. As you know, in the scatterplot, we look at the relationship between two generally continuous variables. However, if you have a lot of data and the points are large, the points on top might obscure points that are beneath them near the same location, and so you can't really see the true relationship. This is called overplotting, where the plotted figures overlay each other and they hide one another. So there's a number of ways to deal with it, depending on the size of the data and how bad the overplotting is. Now, one set of techniques involves just tweaking the aesthetic properties. So if you have relatively small amounts of overplotting, sometimes you can fix it, make it better just by making the points smaller or by using hollow glyphs. The glyphs are the little points, little figures that you're plotting with. So here we'll look at some code that shows some options when you have 2,000 points, considered relatively small, sampled from a so-called bivariate normal distribution. Okay, so we create this data frame of 2,000 randomly generated normal data for both the x and the y axis, and we can take a look at the data frame if you want. We can't see all of it, but it's just x and y, two sets of x and y in a data frame. Here's the top. Randomly normal generated data. Okay, so here we just simply set up the basis for the plot, norm. Remember, ggplot can be done in layers, so we can just set up the drawing frame, which we've done here, and then we'll just add a point, a geom point. So there'll be 2,000 geom points, but the problem is many of them overlay each other. And some of the regions are very dense in terms of overlaid plots, and you don't know where they are. Probably around here, but you can't see the true extent of it because they hide each other. Okay, so one thing you can do is make the circles hollow, and if you make them hollow, then you can see through them. And for example, you can see there's a lot of overplotting here. You can see they're overlaid quite a bit here and here and here and here. And so this gives you a better sense than the solid circles about where the heaviest density of plots are. Or another approach is just simply to make the pixels, the points, smaller, like this. Now, this may be a little hard to see on the video, but you can almost see every single individual one of the 2,000 different points. Very few are obscured, except maybe here, here, here. But see, this gives you a better sense of the shape of the density of the distribution, because now you can see every point. Okay, so those work pretty well with smaller data sets. With larger data sets, you can use the so-called alpha blending or transparency. We mentioned this before, which makes the points transparent. And if you specify alpha as a ratio, the denominator, so here we specify alpha as 1 divided by 3, the denominator, which is the 3, of course, gives you the number of points that must be overplotted or on top of each other to give a solid color. So let's take a look. So this is what it would look like. Now everywhere you see a solid color, solid point, that means there's at least 3 points that are directly overplotted. Let's make it 1 over 5. If we make it 1 over 5, then the solid points become less frequent, and that's because they require at least 5 overplotted points in order to be solid. And there aren't too many where there are 5 points that are very, very, very close to each other so that you get this solid color. Or let's make it more extreme. We'll say 1 over 10. And the solid points start to disappear because the alpha transparency lets you see everything except at places where there are at least 10 points plotted exactly on top of each other. So thus you're getting a better sense of the distribution. Now we could continue this, but the problem is it becomes so transparent you can't see anything. So you have to find the right point, just like bin width. Adjusting the bin width in a histogram to give you the best sense about the data, you have to find the right place, number of points to be overplotted in the denominator of the fraction for this to enhance your perception of the visibility of the data. Now, if the data, some of the data is discrete, and discrete, of course, means it's not continuous, then you can jitter the points. And we've looked at that before with geom jitter, okay? But we're not going to do that example here. Now, one other way, you can think of overplotting as a two-dimensional density estimation problem. So this gives you a strategy, an approach, completely different approach to figure out where the densest places are, where the most points are overplotted. So if you bin them, for example, if you took this and you made little squares, little square bins, and you counted the ones that are in the bin and made the heavier density squares darker, for example, then that would give you some sense. So here we're going to bin it where we have at least 10 points in each bin, okay? And in this case, the lighter ones, this one has 20. This is the heaviest density, and this is pretty close. Okay, the ones out here are very low density. There aren't a lot of points in those little squares. So this is a completely different approach, but you can see where the most dense overplotting occurs here, 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 here. Okay. Now, breaking plots into little small squares is a little distracting, okay? It's not as good as using hexagons because they're square. You can't, in the corner, if you had a hexagon is not circular, but closer to circular than is a square, so you get a better representation. So you can use the geom hex. It's in a different package. It's in the hex bin package. So you're going to have to install this package. Click on line 780 and install it. I've already done that, but I do have to load it into my session with library loads. Remember, you install once and then you load it each time you're using it. Or I could load it, I could go over here and just click off on hexbin. But let's stick to the script right now. Okay, so I load it, and then I say the base norm, which is just the drawing frame, plus geom hex. Okay, and it automatically sets up counts. And again, the lighter ones are the heavier, dense parts of the overplotting. Here, here, here. But because it's kind of round, it's a better representation than the square. Or I could say I want the bins to be exactly 10 instead of having this type of automatic display. I want the bins to be 10. And then it does it. The bins each have at least 10. And again, you see these are the heavier ones, heavier overplotting here. Well, that's it for this section. Next video we'll deal with the last section, I believe, in this chapter 3, statistical summaries.